Today we're going to quickly learn how to calculate average atomic mass for a particular isotope of an element. Okay, in the image above, we're provided mass and percentage abundance information for 4 isotopes of sulfur that exist in nature: sulfur 32, sulfur 33, sulfur 34, and sulfur 36. Each of these have different atomic masses that you can see, but all of these are represented by a single square on the periodic table that has an average atomic mass. How is the average atomic mass on the periodic table depicted here actually calculated? Okay, to calculate an average atomic mass or an average weighted atomic mass for an element, we're going to take the mass of the isotope given and multiply it by its percentage occurrence, but we're going to change the percent to a decimal form. So if the percentage occurrence was 69.1%, we would change that to 0.69. So it's simply mass times percentage occurrence. Once we've done that calculation for each isotope, we will sum the individual mass contributions by each isotope, and that will equal the weighted average atomic mass. And then we'll follow up by putting an appropriate label of grams or atomic mass units at the end. So let's see how that works out. Here again, we have our charts of mass numbers, masses, and percentages abundance. In this particular example, we're going to use the mass number to represent the mass. Ideally, if you want a very accurate calculation of the weighted average atomic mass, you would use the full atomic mass that's given for each isotope. But in the interest of making our computation a little quicker and easier to punch into a calculator, we're going to use the mass number to represent the mass. So for sulfur 32, we'll take the mass number 32 and multiply it by the percentage expressed as a decimal. 95.02% is 0.9502. And when I calculate the answer, this answer, 30.4064, is sulfur's portion of the weighted average atomic mass. Now, I'm going to duplicate this calculation, mass times percent as decimal, for each of the isotopes that I'm giving information regarding. So for sulfur 33, I would multiply the mass number 33 by the percentage as decimal, 0.0075, to get this total. For sulfur 34, the mass number 34 times the percentage abundance in decimal form, 0.0421, to get this contribution. And then finally, sulfur 36, the mass number, times 0.0002, expressed as a decimal, will give this contribution to the overall mass. To determine the average atomic mass, or weighted average atomic mass that appears in the periodic table, I would simply sum these partial answers. So I'm going to add them together, and I will get this as a total: 32.0925 grams. Now, since I calculated using the mass number instead of the actual mass, and the mass number only had 2 digits, then I really don't want to have my answer for weighted average atomic mass extend too far past 2 digits. So my periodic table lists the weighted average atomic mass as 32.066. So in this case, I lost a little bit of accuracy, so I'm just going to ignore the 0.0925 and just call the weighted average atomic mass approximately 32. And you will find, if you calculate the weighted average atomic mass for a real element from the periodic table using very accurate mass and percentage data that you will actually calculate the exact weighted average atomic mass that appears on the periodic table. Now, this is a replica of what is in your notes. Okay, take a minute and copy down the example question on your note page from this slide. Now, to make sure that you get how to do the weighted average atomic mass question, I would like for you to try this problem. A fake element has two pretend isotopes in nature, falcium-85 and falcium-87. If the abundance of falcium-85 is 72.2% and the abundance of falcium-87 is 27.8%, what is the weighted average atomic mass of falcium? Okay, now that you've had a chance to answer the question, okay, let's go ahead and take a look. Okay, if I take the mass number of falcium, 85, and multiply by the percentage, 72%, changed to a decimal, I will get this contribution to the mass. The mass, 87 times 0.278, will give this contribution to the mass. When I add together, I will get 85.556. Since my least accurate decimal carried to two places, I would record this as 85.56. Now that you've had a chance to look and see how average atomic masses are calculated, please answer the final question on your homework paper.